Okay, great. Can you hear me okay? Excellent. Thank you. It's my first time in Portugal also. Of course, it's first time at this conference. I had a great time. It's a great event here. Did you have a good time so far? Excellent. Okay, so in this session, I will talk about 12-factor app, followed by the 12-factor app in action, and to build 12-factor microservices. So hopefully after this session, and you can go ahead to build your own 12-factor app without any problem. I'm Emily Jiang, and I work for IBM. I'm a Java champion, and I work on MicroProfile. Anybody know MicroProfile? Show hands. Okay, great. Also, I work on Open Liberty. Anybody know Open Liberty? Oh, okay, that's good. So hopefully after this session, you will have a fair knowledge about MicroProfile and Open Liberty. I'm the STSM. I work for the IBM Hursley Lab. So one day, if you come to visit the UK, I highly recommend that you go and visit IBM Hursley Lab, which is a really, really nice lab and has a really nice building there, and also great developers there. As I mentioned earlier, I work mainly on MicroProfile and like an open source project, and also the Open Liberty. I lead quite a few specifications, and also I'm the architect for Liberty implementation on the MicroProfile as well. I'm a great fan about cloud technologies and like infrastructures like Kubernetes and Istio and etc. So as I mentioned earlier, these are two parts. I will quickly go through the first part and then dive into the live coding session to create a 12-factor app, which is microservices, and to create two microservices, and then they can talk to each other using MicroProfile, of course. So in the next few slides, I quickly talk about 12-factor app methodology, and also give you a quick overview of MicroProfile, and then dive into the 12 factors briefly. So 12-factor is a methodology, is a best practice, and tell you how to do microservices, etc. And then once you use this methodology, and you can rest assured, and your application can perform well in the cloud infrastructure. It's published by Heroku. It's 12factor.net. Anybody know the 12-factor already? Okay, good. It's about a third. So it's actually, if you want to understand the 12-factor, it's nothing new. 12-factor app is very, very strict to define a clear cut between the application and the infrastructure. It gives you a contract, like which bit needs to be done by the application, which bit needs to be done by the infrastructure. So you don't trip into each other's toes. So this is directly taken from the 12factor.net, is the definition of the 12-factor. So when you leave this session, you should have three things to take away from the 12-factor. One is just a declarative. Basically, you know exactly if you are Java developer, if you are the developer, what kind of things you need to pay attention to. The second thing is which part need to be, which responsibility need to be taken care of by developers, which responsibility need to be taken care of by the DevOps. So clear contract between the application and the infrastructure. And also with this 12-factor methodology is capable for the cloud deployment, and also is great for the CI/CD development. And also it can be auto-scaled, so you can, in a high demand environment, and your microservice can scale up, or in the quiet time, it can scale down without any problems. So basically, in summary, 12 factors define the contract between the application and infrastructure, and also have the cloud infrastructure in your mind when you design this application. So it's suitable for the cloud deployment and also capable for CI/CD pipelines. So this is the 12 factor. So I will go through each in greater detail in a minute. So this is the 12 factor. So the next thing is the microprofile. So microprofile is open source community, basically, for the people to get together to evolve the best breed programming model for doing cloud-native microservices. So it was established over 2 years ago by IBM, Red Hat, Piara, Tom Tribe, and LJC, London Java community, and other individuals. We all come together trying to solve the problem, how to design the best breed and very most simple programming model for Java developers when they try to write microservices. Is completely community-driven, and if you try to understand the macro profile, and if you are Java EE developer, anybody Java EE developers? Okay, great. So it's if you are Java EE developer, you know you have a lot of specifications like CDI, like JAX-RS, and etc. And there's RI, so basically reference implementation. In microprofile, there's no RI. We have a lot of implementations. All of them are equal, so they all pass TCK. We do not want to differentiate one implementation over others. And also, we release very fast. We have like, so far we released, we have done the 8 release so far, overall release. And also, now we trying to do the 3 releases per year. So it's very fast release cadence. And we have a spec released in the GitHub, in the microprofile GitHub release page, API TCK, all on the Maven Central is the free, is Apache version 2 license, the free to use. So this is the implementation you can choose from. In IBM, we have Open Liberty, and then fold into the WebSphere Liberty. And in Red Hat, you have Songtail and SmallRye, which is a library for the implementing macro profile specifications, and also Quarkus. I know later on Barsata is going to talk about Quarkus in the closing keynote. Quarkus is directly consume SmallRye, which is the implementation of macro profile. And also is a Tommy Tribe has Tommy EE, and Cumulus EE, and Oracle has a Helidon, and also Apache Launcher. So there's a lot of application server for you to runtime for you to choose from once you use this macro profile programming model. So this is a release tree. So you can see the less than 3 years, and so far we have so many releases. And the current release is MicroProfile 2.2. At the moment, we are trying to release MicroProfile 3.0. And in Open Liberty, we have a monthly release cadence. Basically, we try to release every month, and also we put MicroProfile on the higher in our top priority list. We really want to implement MicroProfile specifications once it's being released. So this is very important for our developers, for our customers. Okay, let's quickly go through the 12 factors. The first one is the Codebase. So Codebase, like each microservice should have its own repository, its own project. So in this case, like this single team can directly do like a PR and directly review each other. They can have a dedicated different release cadence and etc. So this is Codebase. When you do like 10 microservices, you don't intend to put all 10 microservices in the same GitHub repository, which is not best practice. As very soon you entangle each other. Okay, so far, how many of you are doing microservices? Okay, few. And anybody like one single microservice using its own repository? Okay, good. The second one is dependencies. When you try to do dependencies, remember like nowadays, I think Maven is still like more popular than Gradle anyway. So mainly the Maven or Gradle. So you put the dependencies if you Maven in the POM XML, do not package your libraries directly inside your application. You should always mention the dependency in your POM. You can consume the latest version, and you don't want to get stuck depend on hard dependency on some libraries inside your application. You can never move forward. The third one is the config. You should always externalize your configuration. So you want to make your microservice build once, config everywhere. So build once, run everywhere. When you deploy your microservice in the one environment, you can directly configure the value. And then you can deploy your microservice in the different environment. And then again, that environment can directly configure the microservices. Do not need to, if you want to change the value, you shouldn't need to repackage your application. So it's for the config, externalize your config, you can use MicroProfile Config to directly inject the config value from the config sources, and then you can change the value in the config sources. In this way, your application shouldn't need to know where the value from and etc. It's just consume the value. So if you use Kubernetes, you can define the config value in the config map or secrets, for example. So the backend services, you should treat the backend services as attached resources. So you can easily swap out. For example, okay, you have attached resource to Twitter, or maybe you don't want to Twitter anymore. You can easily slot in the Facebook, for example. So it's very flexible. So you can configure this external service as well using the config. So you can directly configure to a different backend. So build, release, and run. So you should strictly separate build, release, and run. So when you change the code, you should build and then go to release and then go to run. Obviously, you should consider to use the CI/CD pipeline, the tools to enable the CI/CD, make the continuous integration, continuous build is as simple as possible. So there's a lot of tools for you to choose from. The sixth one is the processes. So all the processes should be stateless. The reason is why they should be stateless is because if you deploy as a microservices, it will be like a container in pod. The pod can be killed at any given time. And then if the pod is killed and Kubernetes stand another one, you lose nothing if it's stateless. However, if it's stateful, you will lose something very valuable. The pod binding. Remember, after you have defined your microservices, and when you test locally, you know, okay, I bind in the port 9080, for example, or 8080. And then later on, when you deploy to Kubernetes, Kubernetes will give you a different port. So you should always bear in mind, okay, this port should not be hard-coded in your application. It should be configurable. So you can always use the deployment YAML file to configure the port. So go to the different backend, for example. Concurrencies. So the concurrencies, this is the kind of deal with solve the problem is under heavy load. So your processes should be scaled up. And if it's a quiet time, it should be scaled down. So you can use, if it's the concurrency feature, is automatically scale up or scale down depending on the load. So in this way, you only pay for the resources you need in the cloud. So if it's quiet, you scale down and you pay the less money. If it's a heavy load, you scale up so you can serve more customers. The next one is the disposability. And if you I mentioned a lot about deploying microservice to the cloud. When you do the microservice, obviously your next aim is where it should be deployed. The obvious answer is in the cloud. No matter it's a private cloud or public cloud, is the cloud. If it's in the cloud and every minute it's running, and it will consume resources, will cost you money. So if you want to save the cost and make sure your microservice can start up fast and then shut down gracefully. And also need to make sure your microservice is resilient. It should perform at any given situation. So later I'm going to do a quick demo about how to make your microservice very resilient, fault tolerant. And the other thing is when you are building microservices, you should treat your microservice as cattle, not pet. You know, if we have pet, we attach to it. It has its own personality. It has its own name. If it gets sick, we have to take it to the to the vet, for example. But if it's cattle, all the cattle looks the same. So if one cattle is is not well, and you can easily replace it with another cattle. So we should always treat the microservice as a cattle, not pet. The next one is the dev prod parity. So basically, you should make the dev and the prod as simple as the same as possible. So in this way, you can guarantee that if you test it in the development environment, it should work exactly same as the production. So the way to solve this one is the obvious answer is to use Docker. So basically, the once you get it working in the development, you create a Docker image and directly deploy to Kubernetes, and it has everything it needed to run to perform in the live environment. And also, is when you deploy even to the Kubernetes, you can use the Helm chart. And to make sure every time you use the same script and directly deploy it. The logs is very easy, very interesting as well. And when you trying to do your business logic, you forget, okay, I need to log out. Actually, if you want to service your microservice, you should always remember to do some logging. So it's very important for the support team. So you should always remember to log a very important state and etc. And in the microservice environment, your microservice is running in a pod at any given time, maybe that pod will disappear. You should pay more attention to how can I make sure my log will not get deleted or go missing. So one is the kind of best practices. You can directly live streaming out the logs, use the system out. And also, you could plug in the Elasticsearch, for example, directly gather all the logs. So the final one is the admin processes. So you should run the admin processes as a job, not put inside your application. The reason is you should make the application as concise as possible. So for these one-off processes, you should always code it as for example, Kubernetes job. And then you can schedule it and do whatever you want, and also can collect the logs, for example. But if once is part of our application, that application carries this unused line code all the time, which is not good. It can use memory and for no apparent reasons. Okay, so that's a quick summary of the whole 12 factors. So quick, let's quickly go through this 12 factor again. Codebase, you can use GitHub. use one single GitHub repo for the per microservices. Dependencies, you either use Grid or Maven and declare the dependencies. Config, so you can put the config value in the config sources and then directly using MicroProfile Config to inject into your application. The backing services, you can use the config again to bind to a different microservices as a backend. And build, release, and run is best practices. You should have a clear phase. Build and release and run, or consider to use the CI/CD tools to help you. Processes, you should design the stateless processes so that your microservice is stateless that can grow or can shrink. Port binding is do not hard code your port because once it's deployed to the service mesh or Kubernetes, for example, the port will allocate dynamically, so it will change. So you should always be able to configure it. You can use the MicroProfile Config to directly bind to a different port. Concurrencies, this can directly help about Kubernetes auto scaling. Disposition, and this is your microservice startup fast and shrink is shut down gracefully. Also is resilience. You can use MicroProfile fault tolerance to solve the problem, make sure your microservice is resilient. Dev product parity, again, is best practices. So in this way, it's like written once and running everywhere. So use Docker. So logs, you remember, is you should always log a very important information and also make sure you stream out the logs. Admin processes, do not put the admin processes inside the application, always design the job. So again, that's the Kubernetes job. Okay, so quickly, like I mentioned the MicroProfile Config, I mentioned the fault tolerance. I'll quickly give you a quick overview of MicroProfile Config. So you define the config in the different config sources in the file or in the as a system property or environment variable, and also like a Kubernetes config map. You can define the property, and then you can inject using the property or using the programmer API can directly look up the config value. So you can use config provider.config and then config.get value to directly find the value. And then or you can use the CDI to directly inject the myString.properties and into this variable. So the fault tolerance is very simple. It's basically the annotation based. We have this annotations retry. So basically the try again if it failed. And the circuit breaker if it's repeatable failures and with the configured criteria, the circuit will be tripped open. And then you will get exception straight away instead of waiting for the timeout. And the bulkhead is the constraint the concurrent request. So this makes sure your one microservice will not bring down the whole application. So timeout, so you shouldn't, you should always have this timeout concept. Basically, you don't want your customers to wait, forever. The final one is fallback. Fallback, this is the last resort resolution to cope with any kind of failures. If you cannot cope with the failures, you should always come up with a fallback logic. Basically, it's if you know Istio, anybody know Istio? Okay, if you know Istio has quite a lot, most of the fault tolerance aspect, but it cannot do fallback because fallback needs business logic. So it's one thing is this can work quite well with Istio. You can directly plug in the fallback and directly work with Istio's fault tolerance. For example, you ask Istio to retry install, you retry yourself. Okay, so next one. So is I mentioned quite a bit. So how can I get started? How can I build microservices, for example? So the first thing is we have the MicroProfile starter. Basically, it's create a microservices. So let me quickly go through. So in the next half of this session, I will do a code demo. So basically, it's create a microservices and to use the 12-factor methodology. So okay, so this is the start of MicroProfile.io page. So I can create at first. Okay, I create one microservice. For example, I see JSB. So this is my microservice, and also I can choose which microprofile version. So can you see? Okay? Yeah. So it's the latest version, MicroProfile 2.2. Once you use this, and then you can choose a different runtime. At the moment, OpenLiberty and Songtail has an implementation. Okay, I choose OpenLiberty. Actually, I don't really want this. For example, maybe I just use the health check and create the client. Okay, that's been done for me, and then let me make it bigger. So I go to download, and then JSB. I just do a Maven install, and it will build the microservice. So use this OpenLiberty 905 image, and then packaging in the server. So after that, I can just use Java -jar. There's a jar being built, for example, JSB.jar. So I can start it. And then I know it's 8181. Later on, it will directly point it out. So that is the JSB. So this is my microservice. So basically, nothing fancy, just say hello world. So now I can directly use my editor. So anyway, I use Eclipse for a long time. So I use all sorts of editors, IntelliJ or Eclipse or VS Code. And today I use Eclipse. So I can directly import my Maven project. So I browse. So JSB, open, finish. So here is my source code. So it's directly create the JAX for me. So this is, let me make it bigger. So this is the JAX application, and also this is my controller. So if I basically I would like to do something. I want to directly do a fault for here. So I will say, okay, every 3 times. If I do every 3 times, my microservice will fail, divided by 3. And then I throw new runtime exception. I know. I finish. Okay, so in here, create. So I can build it. Okay, I let it running, and it will come back shortly. And in the meanwhile, this is kind of, I did my first microservice. And now I would like to create another microservice. So I want to do the JSA. So okay, so again, it's the MicroProfile 2.2, and again, it's Open Liberty. So again, I just want to use the directly do the health check, and then download it. Okay, this is my JSA. Create a new window. So I'm in here. Now I directly import my JSA into my IDE. So I import. So I'm in here. Let's see here. This is my service B. I put 4, and you can see hello world, and sometimes it's not working. This is a kind of represents. I just create real life microservices, because you can sometimes you will just have bug in the code here. So now in my service A here, is nothing fancy here. So directly I have again the JAX-RS, so the application, and again is just a hello world. Okay, in here, actually I don't really want to create a standalone microservice. I want to call into service B. How can I do it? So let's first find out what does the service B's capability like. So you can easily just use the Open API. So you can just say Open API. This is the service B's functionality. So you can see, okay, it's on the localhost 181 JSB and data hello, and then is kind of the return string. So, and now, in service A, I know what's the interface like. I can directly create an interface, service B interface. Save the time, I can directly copy this file. I'll show you. So service B, so here, this is service B's get operation and say hello and then return a string. And the base URI, as I showed earlier, is here is the JSB, right? JSB. So I directly create an API there. So next one is what I only need to do, I need to inject. That's the MicroProfile REST client. I directly inject the API, the service B API into my service A JAX-RS resources. So how can I do it? I can just do a add inject. I see that REST client. And then I do a service B client, service B. And then here is then I say hello world. I just say calling instead of service B dot. So I can just directly say hello, like that. Okay, so okay, so this is the kind of directly plug-in that. So I know it's at the moment, okay, we directly plug in the microservice A, can directly call it microservice B. So in Open Liberty, all these the microprofile starter, it uses different runtime plugin. In Open Liberty, we use Open Liberty plugin. At the moment, we are doing a development mode for Open Liberty, which I want to demo to you. So basically, is in the development, you can automatically to see what the code, what the result is like while you are coding. So the latest Maven plugin is 265. I directly installed locally in my local Maven repository, so I can directly put in here. At the moment, the version is 26.5 snapshot. Can do that. So now, in the SA, I can do a Maven clean install. So let it finish building. And then I do a Maven Liberty dev. I want to run in the dev mode. So when you run in the dev mode, it's automatically reload the classes, change any files, and also be able to run the test automatically as well. So you can see here. So let's see here. Let's go to see here. Oh, okay. One thing is not quite working as yet, so I need to change the port. So I want here is bind to a different port because I already bind 8181 to the other service. Let's see. Do I need to restart? NTT JSA. Okay, let me restart it. Okay, I need to restart it, so that's fine. I do a Maven install Liberty dev. Okay, so it's starting the server now. Let's go to the console here. See, it's saying, and then, okay, calling hello world. The hello world directly written from service B. Okay, so you can, this is demonstrate two microservices can talk to each other is using MicroProfile REST client. I have no, go through in the presentation, but later on I'll give you a quick link. And so it's very simple. It's the kind of directly you put an interface in the calling service, and then you directly inject the backend and then bind the backend URL there as well. As I have demonstrated, and sometimes it's not working, and sometimes this is a real life example because you cannot control the backend, and sometimes they're owned by a different company or owned by the different team, and you haven't got any information how to fix the problem. Now you can think yourself, how can I solve the problem myself? You can only change yourself to fix the problem. Let's see how can I fix this problem. So just by changing my own code. So mine's the service A, right? Service A is directly calling service B. So actually, the first thing I can think, okay, I use microprofile for tolerance. I just directly do a retry. I save it. So now, let's go back to see. See, it worked all the time. So this is the kind of open liberty dev mode. Automatically add one line code. It's automatically recompile the class, and it's also automatically get the new information, new class from the class is directly, and directly is restart the application and reload this new change, new version. So it works. And sometimes you say, okay, retry, that's nothing fancy, right? And sometimes you cannot use retry to fix all the problem. Okay, I mentioned earlier, actually, you can plug in your own fallback. So you can directly say, okay, I can do a fallback, for example, fallback service. I can say, okay, I return. This is my fallback. Okay, how can I make sure, okay, this one uses my fallback? I can just use the annotation and say, okay, it's a fallback. If you failed sometimes and do a fallback service, call here. Save it. So if this got exception, if this one got exception, it directly call this fallback. Let's demonstrate to see whether it works. See, it automatically go to fallback, and then this is successful, and third time is go to fallback. So that's kind of demonstrate how to build really resilient microservices. So change your own code and cope with all kind of error situations, and you can build resilient microservices without relying on the backend to be bulletproof. Okay, this is one thing is build for tolerance microservices. I also mentioned in the 12 factor is externalize your application, externalize your configuration. So at the moment, in this hello service, I really want say some person's name, like a username. I say hello this person, or hello JNation, and hello James, and etc. And I want to config it. So how can I get that done? So basically, in MicroProfile Config, you can directly create some properties here. So I can say, okay, now I can just here I can say Emily. I save it, and I directly inject. I inject config property, say name equals username. String username. See like that. I directly inject. And it doesn't matter where the username is defined. At the moment, I define is MicroProfile config properties. Later on, you can define it as a system property or environment variable or in your Kubernetes config map. So here, I can just directly say, hello, username. And now, let's go back to here. See, hello Emily, calling. And I even, if I change this value here, I say JNation. I change this file, and I go back here. Hello JNation. So this change directly picked up by the Liberty dev mode, this plugin, by Liberty plugin with the dev mode capability. And this plugin will be in the MicroProfile starter very soon, because at the moment we are trying to put the code into release and etc. It will be available to you very soon. So this is I quickly demonstrated the MicroProfile for tolerance and a REST client, and also the MicroProfile config. How can you inject your configuration from various config sources into your application? So the MicroProfile config is very useful, because if you define, for example, username here, I define in the MicroProfile-config.properties. And then when you deploy to the Kubernetes, your DevOps can directly define username in the config map. And then is your application, your microservice will not need to be repackaged. It's directly use that value defined in the config sources. It's because the config source has a priority. The file base, the MicroProfile-config.property has the priority or ordinal code is 100, and then the environment variable has a priority or called ordinal is 300. So it's a value defined there will overwrite the value inside your application. And then you also can define any config sources yourself as well. So with that, do you think it's simple enough? You can do it yourself? Yeah? Are you impressed? My demo worked. So I see that I always want to do the clean code. I always want to do the simple code. I want to define the MicroProfile as simple as possible. Anybody can use it. Give you a quick example. Like I have graduates to work in my team, and then I give her a job to write using the MicroProfile config. Is oh, can you spend half an hour to talk to me about it? I said, okay, this is the doc. Have a read and come back to me if you still need help. And then she just read the MicroProfile config spec, and then she got it straight away. So that's the beauty of to be simple. So it's very easy to get on. Let's quickly go to the slide again. Hopefully, okay, cool. If you want to get to know more about MicroProfiles, there's openliberty.io/guides. It has every single MicroProfile specification documented with the example there. Is a GitHub repository. You can directly clone it, and you can see how it works. Each guide only take about 30 minutes, or sometimes it's only 20 minutes to get started. And later I give you a quick demonstration there. So it's when you leave this room, hopefully you will check out the microprofile.io and then use start.microprofile.io and get to know a little bit more about MicroProfile. You can use openliberty.io/guides for the demonstrations. So back to the 12-factor, basically is use MicroProfile and Kubernetes and best practice. You can do the 12-factor without any problem, and very simple as well. And this is again the recap the 12 factors. And this is a good references, the links you should take away with, like microprofile.io, Open Liberty, 12-factor. And I have my personal GitHub, and directly I have a 12-factor app A, B, and also deployment. This one, today I did a demo Minikube and etc. In my example here is 2 microservices that can be Dockerized and deployed to Minikube. So you can see how can you use config map to directly do the port binding as well. So last but not least is if you are thinking about app modernization, anybody trying to do the monolith to microservices journey, start that journey? Oh, cool. If you are thinking about the app modernization in September 9th and 10th in Hursley, which is where I work, actually, Hursley IBM, we do a modernization Hursley Summit. It's free for registration. You can come to listen to the lot of talks about modernization, also about microprofile and microservices, and etc. So with that, thank you, and obrigado. Did I get it right? Sorry, I don't have any time for questions. So, however, I will be outside this room. If you have any questions, come to talk to me. Thank you. Thanks.